Hello everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, I will be discussing this lesson about the properties of similarity in plane figures. In our previous episode, we already studied the meaning of similar figures and its symbol. Also, I discussed about the similarity ratio. Okay, this time, let's talk about the properties of similarity in plane figures. Okay, as you can see in this slide, there are two right triangles. And these two right triangles are similar figures. This side of this triangle corresponds to this side of this triangle. This side corresponds to this side, and this side corresponds to this side. Okay, the first property of similar figures that you need to understand and remember is the ratio of the length of corresponding sides is constant. Okay, what does it mean by this first property? Okay, as what I've said a while ago, this side corresponds to this side. Given that this is 4 centimeters and this is 8 centimeters, if we are going to get the ratio, then it would be 4 is to 8. Simplify, it's 1 is to 2. So the ratio of this corresponding side is 1 is to 2. Since the ratio of the length of corresponding sides is constant, then it means this corresponding sides ratio is also 1 is to 2. This corresponding sides ratio is also 1 is to 2. Okay, let's check. This is 3 centimeters, this is 6 centimeters. So 3 is to 6. Simplify, then it would be 1 is to 2. Okay, what about these corresponding sides? This is 10 and this is 5. So 5 is to 10. And if we will simplify, it's also 1 is to 2. So the ratio of the length of corresponding sides is constant. Okay, moving on to the second property. According to this one, the measure of corresponding angles are equal. Okay, in this figure, since these are similar figures, this angle corresponds to this angle. This angle corresponds to this angle. This angle corresponds to this angle. And the measure of these corresponding angles are equal. Okay, now, if the ratio of the length of corresponding side is not constant, and the measure of corresponding angles are not equal, then the two figures are not similar figures, or the two figures are different figures. Okay, moving on to the third property. If the similarity ratio is m is to n, then the ratio of their area is m squared is to n squared. So in short, we are just going to square the given similarity ratio. Okay, before we will give an example, let me discuss first how are we going to find the ratio of the perimeter or the ratio of their perimeter. So we all know that perimeter is, okay, the sum of the length of all the sides. So in here, this is 5, 4, and 3, so this is 12. What about here? 10, 8, and 6, 24. And if we are going to get the simplified ratio, this is also 1 is to 2. So the ratio of the perimeter of similar figures is the same as the ratio of the length of corresponding sides. But when it comes to the ratio of their area, we have to square the given similarity ratio. So in here, we got 1 is to 2 as the similarity ratio. So to get the ratio of their area, we just have to square. So 1 squared is to 2 squared. And this is now equal to 1 is to 4. So this is the ratio of their area. Okay, let's give another example by answering this concept check question. Quadrilateral ABCD is similar to quadrilateral EFGH, and the area of quadrilateral EFGH is 8 square centimeters. We are going to find the following. Okay, let's take a look at these two figures. And according to this problem or to this example, these are similar figures. It's given that the area of quadrilateral EFGH or this quadrilateral is 8 square centimeters. Okay, if you are trying to look at this one or if you are trying to understand these figures, since these are similar, okay, this point A corresponds to E, B corresponds to F, G corresponds to C, D corresponds to point H. Okay, so it means this side AB corresponds to this side EF. Okay, we have given here that the area of this quadrilateral EFGH is 8 square centimeters. Okay, so this bigger figure, flip and make it smaller, then this is now the smaller or the reduced version of this bigger version. Okay, now let's find the length of segment AB or this side of this quadrilateral. Okay, in order to find the length of this segment AB or side AB, okay, we are going to find first the ratio of similarity. And to find the ratio of similarity, we are going to use the length of this side FG and this corresponding side CB since BC, since all the lengths are given. So this is 6 is to 4. So if we will simplify, this is now 3 is to 2. So the ratio of similarity is 3 is to 2. Okay, to find the length of side AB, let's represent this side as x. So ratio is 3 is to 2. So this is now equal to x is 2. This side corresponds to this side, and it's given that this is 2 centimeters. So x is to 2. So this is 2x is to 6. So it means x is 3. So this is, or this side is 3 centimeters. So 3 centimeters. Okay, next question is, what's the measure of angle D? Where's angle D? This angle. Okay, going back to the corresponding angles or points, this angle E corresponds to angle A. So this is 100 degrees, so this is also 100 degrees. Angle F corresponds to angle B, 90 degrees. And then angle C corresponds to angle G, so this is also 60 degrees. What about angle H? We actually don't know yet angle H, and this angle H corresponds to angle B. Okay, let's find angle H since we already know these three angles. So we just have to get the sum of these three angles and subtract from 360. So this is 190 and 60. 90 plus 60. And this is 250. So subtract from 360. So it means this angle is 110 degrees. So angle D is also 110 degrees. So measure of angle D, 110 degrees. Okay, for the last question, what would be the area of quadrilateral ABCD or this quadrilateral? Okay, since we already know the similarity ratio, which is 3 is to 2, and it's given that the area of quadrilateral EFGH is 8 square centimeters, then 3 is to 2 is equal to, okay, we are looking for this area. So let's say this is A, or quadrilateral A is to the area of this quadrilateral EFGH, which is 8 square centimeters. Okay, now we just have to square this similarity ratio. So this is 9 is to 4 is equal to A is to 8. Or what would be the area of this quadrilateral? Okay, looking at this one, this is 4. How did it become 8? We just have to multiply it by 2. So it means to get the area of this quadrilateral, we just have to multiply also 9 by 2. So the area of quadrilateral ABCD now is 9 times 2, that would be 18. So it would be 18 square centimeters. So 18 square centimeters. Okay, this time, let's answer the following questions. So this would be our first problem. Triangle ABC is similar to triangle DEF, and the similarity ratio is 3 is to 2. If the area of triangle ABC is 108 square centimeters, then find the following. So these are our similar figures. This is the bigger triangle and this is the smaller triangle. But take note, they are similar figures. So it means the ratio of the length of the corresponding sides is constant and the measure of the corresponding angles are equal. Okay, the first question here is, what would be the perimeter of triangle DEF? So this triangle, DEF. We just know that this side is 10 centimeters. We don't know this side, and we also don't know the length of this side. To get the perimeter, we have to know the length of each side. Okay, first, let's find the length of this side of this triangle. So what would be the length of this side? Okay, to do that, we can make use of the similarity ratio and its corresponding side. So this side AB corresponds to this side DE. So ratio is 3 is to 2. That would be equal to 15 is to, let's say this is X. So 2 times 15, that would be 30. So this is now 3x. So it means x is equal to 15. So it's 15 centimeters. So this side is 15 centimeters. Okay, now, what about this side? EF. So side EF corresponds to side BC. So again, let's make use of the similarity ratio, which is 3 is to 2. So let's say this is y. This side is y. So this is now equal to, this is 18. So 18 is to y. Okay. If we are trying to find this length, from 3, how did it become 18? So we can just multiply by 6. So it means to find this length, then we have to multiply this one also by 6. 3 times 6, that would be 18. So 2 times 6, that would be equal to 12. So y is equal to 12. So it means this is 12 centimeters. Okay, now that we know all the length of this triangle side, then we can now find the perimeter. So 10, okay, plus 12, and we have here plus 15, then this is now equal to 37 centimeters. So perimeter is 37 centimeters. Okay, moving on to the second question. This is what would be the area? According to this, find the area of triangle DEF or this triangle. Since we are finding the area of triangle DEF, Okay, we have to square the given similarity ratio. So 3 squared, this is 2 squared. Okay, this would be equal to, okay, it's given that the area of triangle ABC is 108 centimeters. So triangle ABC is 108 is 2. Let's say the area. What would be the area of this triangle? So this is now 9 is to 4 is equal to 108 is to the area of this triangle. Okay, this is 9. How did it become 108? Then we just have to multiply this one by 12. 9 times 12 is 108. So it means it's 4 times 12. Then the area of triangle DEF now is, okay, we have here 48. So it's 48 square centimeters. So 48 square centimeters. Okay, and for the last question, according to this question, the similarity ratio of circle O to circle prime O is 2 is to 3. And the area of circle O is 8 pi square centimeters. What is the area of circle prime O? Okay, so it's given that the similarity ratio of circle O to circle prime O is 2 is to 3. So this is 2 is to 3. Okay, and the area of circle O is 8 pi square centimeters. So the area is 8 pi square centimeters. So we're looking for the area of circle prime O. So let's represent this one as A. So what would be the area of circle pi O? Since we know that the similarity ratio is 2 is to 3, then we just have to square the similarity ratio. So 2 squared is to 3 squared. This is equal to 8 is to, what would be the area of circle prime O? So 2 squared is 4. This is 9. And this is equal to 8 is to A. So this is 4 and this is 8. So how did it become 8? Just multiply it by 2. So it means this is also times 2. So the area of circle prime O would be 9 times 2. So this is now 18. So 18 square centimeters.